We start in Mentat in the Geometry and Mesh tab. Firstly, I'm going to click on the grid. I'm going to change the dimensions of the default grid with Edit. U domain, I type in at the bottom 0 space 50, that's because I'm working in millimeters. And V domain, same again, 0 space 50. And I just want to change up here, I want to change that spacing to 2 millimeters. And this one to 2 millimeters as well. And if I click on Fill View, I've got my grid of 50 by 50 millimeters, which enables me to generate the geometry for the profile of the piece seal. So to begin with, I click on that Geometry and Mesh here, and I'll just bring that down a bit. And I'm going to change the curve from line to circle with center and a point. So this is going to be the hollow part of the piece seal. So I'll click on there and we'll give it a point there. Sorry, I forgot to click on Add. So there can be my center, and there's the outer diameter of the seal hole. To improve the visualization of the curves, I can go into View, Plot Control, Curves Settings, click on High there in the middle, and Regen. So now you can see we have a good looking circle, and all the curves and circles will be at that higher resolution from now on. Okay, so I click OK to that. Now I want to use an arc, which is going to be arc with a center and point till it extends. Click on Add Curve. There's my center again, and in Mentat you want to click on a point thinking in the anti-clockwise direction, going round from there to there. That gives us our smooth curve. Okay. Now I'm going to add some straight lines to that seal shape. So I change from arc to line. Click on Add, and then I'm going to come down here and draw some lines to there, from there to there, from there to there. Now, to make it look a bit more like a real piece seal, I'm going to put in some fillet curves. So Add Fillet, select the first line and the second line, and then type in at the bottom the radius you want. So I'll put in 3 there, hit Return, and we have that fillet. Do the same over here, first line, second line, hit 3, and there's a second fillet radius. Right. Now what I'm going to do is tell that profile the number of curve divisions. So up here you can see curve divisions, and I am going to use number of divisions, sorry, target length I'm going to use, and I'm going to make that 0.6 millimeters. So if I apply the curve divisions to those curves, select those curves, right click on the mouse, and you can see that's a relatively fine mesh. It's probably too fine, in fact I'll change that. Let's just go back to 1 millimeter. Apply curve divisions, select the curves, right click again, that looks a bit more like what I want. Okay, now I can mesh that profile. If I go into Auto Mesh and Planar, I click on Quad Mesh and then select those curves, right click, now gives me a mesh. Right, I'm happy with that. To proceed, that will be the rubber elements. Now, just to tidy that up a bit, I'm going to remove the nodes using this icon on the right with the red dot. and I'm going to hide the curves that are the outer profile. So to do that, I go into View, Visibility, Make Invisible, click on Curves, and select all those curves again, right click, and those curves have now gone. Right. Now I am going to add a material for the rubber. So if I right click in the Model Navigator area here on the left, it comes up with various options. I'm going for Materials, New Material, Finite Stiffness Region, and Standard. Okay, I'm going to name the material Rubber Seal, and I'm going to tell it on that form that I want it to be an Ogden material model. In moduli, I'm going to enter a nominal 0.5, which these are just numbers I know will give me a reasonable hyperelastic type material with relatively soft rubber properties. Okay, once you do that, the form automatically calculates a bulk modulus, but if you're not happy with that, you can put in a manual bulk modulus. Now I need to tell it that I want all the existing elements in the model to be that rubber material. So I click on Add, and I click on this left green icon for all existing. Okay, so 615 elements are now rubber seal. Okay, click OK. There I have my material. Next, I'm going to produce a table for the loading, because I want a ramp loading. And again, right click in the Model Navigator area, New Table, one independent variable. I'm going to call this ramp. Okay, it's good to give everything a name so it makes the menu a lot clearer. Type is going to be time. Okay, and I'm going to add data points now, just 2. So click on Add. In the box at the bottom, I enter 0 space 0 for the first point, and 1 space 1 for the second point, and it plots the ramp that I want. It goes from 0 0 to 1 1. Okay, click OK, and that's my table ramp created. Okay, but to get back to the model view, we click on the red M up here and click on Restore, and we can close that table window now. We don't need it anymore. Now I'm going to go back into Geometry and Mesh, and I'm going to add a new curve for representing the door. So click on Add, from there to there, let's say. That is going to be our door. Now I'm going to create a contact body from that door. So I right click in the navigator area, Contact, New Contact Body, Geometric. Here, Geometric. I'm going to call it Door, make it nice and clear, and I am going to add that curve by clicking on the curve and right click with the mouse. But I need to tell that door that it needs to move downwards, so I'm going to change from velocity to position control. I'm going to put in some parameters, and I want it to move down in Y by, say, 15 millimeters, so minus 15. That will make that curve move downwards by 15 millimeters. And this is where we use the table. We call up table ramp, so it will gradually or linearly move 15 millimeters throughout the course of this analysis. So that's done. Click OK, and OK again for the door. Now there's something we have to watch here, is that each line or curve has 2 sides to it, and when contact is involved, you need to make the back face of the curve facing away from the flexible body, which is the rubber seal. So to find out, we can right click on contact bodies and click on Identify, and this is the wrong way round. These short lines need to face away from the flexible body. Now to put that right, up here we have Tools in Contact Bodies, and underneath that drop down menu it has Flip Curves. So I'm going to click on that curve now, right click will reverse it. So that is all good. I'm now going to create a contact body for the base which I'm going to fix. Okay, so back into Geometry and Mesh, add a curve again from there to there. Okay, and I'm going to now right click, contact, new contact body, geometric again, and this is going to be called base fix. Obviously you can call these things whatever you like, whatever you prefer. I'm going to add a curve, that one I just created, right click, and so we've got one curve in base fix. I don't need to add any body control to this because I want it to just stay the default, which is static. Okay. Now again I want to make sure that that's the right way around, but if we look closely this has got little short lines facing upwards, which is the wrong way round. So in Contact and Tools I can flip that curve, click on that there, right click, now it's the right way round. So that's good. Okay. Now I'm going to turn off the grid because I don't need it any longer. So in Geometry and Mesh, just uncheck that grid box. Okay, so it looks nice and clear. Now I want a contact table to tell Marc which bodies can touch which, okay, and which are glued to which. So if I right click in the navigator area again, click on Contact and New Contact Table, here we have two items. Now that reminds me I've forgotten to make the flexible contact body, so I'll click OK there. Contact, new contact body, meshed. Right. So this one is going to be called rubber seal, not rubber sole, rubber seal. Now add elements. This left hand green icon means all existing elements, so I'll click on that. So we now have a rubber seal with all the elements in it. Now when I click on the contact table, or double click on it I should say, we have three items which can touch each other. And I'm going to tell it how to do that. What I'm going to do is use this default at the bottom. I'm going to say the default is all touching. Okay. Isn't quite what I want, because I want the rubber seal to actually be glued to item 3, which is base fix. So I'll click OK there for now. Now this interact 2, that contact table, me pressing default touching, has created two mesh interactions. One is meshed to meshed, so the rubber to itself, and one is meshed to geometric. And this one, if we open it up, we will see that it is a touching type. And I'm going to, while I've got that open, I'm going to add that friction to that. I'm clicking on the friction button there, and I'm going to put in a friction coefficient of 0.2 and say OK to that. OK again. I'm going to then copy interact 2 because I want a glued version. Okay, so interact 3 is going to be my glued version. So I'll change here from touching to glued and click OK. So I can rename them now. So I'm going to call that glued. Alright, I'm going to rename the first one touch. Okay. Now if we go into the contact table, we've still got touch, 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 but I want 3 to the rubber seal to be the glued. So if I click on that T, I can change the contact interaction from touch to glued because I've created it now, and click OK, and that's my full contact table set up. So the rubber seal can touch the rubber seal. It could come down here and get squashed against itself. The rubber seal can touch the door, which is what I want, and if you remember, we've now got friction specified between those two, and the rubber seal is glued to the base fix, which is my curve down here, which won't move. Okay. Now, before we run it, we need to set an element type for the hyperelastic material element. So if you right click in the model navigator area, under jobs there's element types, and our analysis dimension should be set to planar because it's all two-dimensional. If you click on solid, the quad 4, all the elements in the model are quad 4s, although some have been degenerated into triangles. It doesn't matter because we can still choose the element type here. So we want plane strain, full integration with Hermann formulation, so that's number 80, and I'm going to click on the all existing elements for 80. So every element in the model is now that type. Click OK. Now we need a load case. You can't run a job without a load case, so we'll say one new static load case. We need here to put in the contact table that we've got, table 1. Say OK, so that's set up. The constant time step of 50 of 0.02 is suitable for this analysis, so I won't change anything else on that form. We now need a job, so right click again, jobs, new job, structural. Job 1, I'm going to change that to friction. Okay, so it's with friction. I've got an available load case here which I want to click on and put it into selected. Now I'm going to go to analysis options, change from small strain to large strain, because hyperelastic elements do need large strain. Click OK to that. On the left I've got contact control. I do want initial contact because I want this gluing of the curve to the rubber elements to take place right from the word go. Okay, so I've put in my contact table there and click OK. Before I close that, actually, I want to put on friction, Coulomb friction. That means that I've got control over whether I use the friction at this stage of just before I run the job. Okay, so creating the actual job. So now I've got friction switched on. I need to tell Marc what job results I want, and I would like to have some strains in the results, so I will click on total strain here and click OK. I can now check the model, clicking the check button, and there are a few messages down here saying no errors and no warnings, so that means we are ready to submit the job to Marc, which we do by pressing run. Save the model first. This is the job, friction, we're going to run with friction, so I submit that for analysis. So it is now writing the .dat file and submitting it to Marc. Marc is now running. As we can see, the analysis time creeps up from 0 to 1, hopefully. If it gets all the way, it will reach 1, and it is saying complete, which is all good news. Exit number 3004, which is normal exit number for Marc. So now if I want to see the results, I just click on this button saying open post file. That closes those windows and opens a new model plot results window. Now, just to quickly show the deformation of the P-seal, I can just go into press play, and we can see that the door is coming down and squeezing the rubber seal, which is slightly moving to the left, but not as much as it would have done had I not had the friction turned on. Okay, we can now display the strain by changing this to contour bands under scalar plot, and changing from displacement X to, let's say we use the major principal strain. Okay, now let's go back and play the increments in sequence. So here you see strains increasing. The blue areas are compressive strains and the yellow are tensile strains. So there's a lot of bending going on, as you can see. So while I've got the model here, I'm just going to do another run. Let's reset that to 0. Come out of the results with this red cross icon at the top. I'm going to copy that job, and I'm going to double click on the new job and call it no friction. Okay, and in the contact control I can turn off the friction, so this particular run will run with no friction, everything else will remain the same. So say run, save model, submit, which is now writing out the model again. It's running pretty quickly, and it's complete. So this button takes us to the results again. I will click on contour bands to show the strains and press go, play. So here we are, there's no friction in this model, and you can see that it is deforming further to the left, and that's it. They are the strains with zero friction. I hope that's been helpful to you. It's a very simple model, but it involves hyperelastic material and nonlinear contact.